All right, I'm just going to give a quick little demo here of kind of how to use the Caesar Cipher, use some basic string commands. Okay, I wrote some code here. I'm going to walk you through this. First of all, it's always a good idea to comment your code. That way you know what it's doing. Okay, I just put a string in here. I called it my string, and I set it equal to today is the day, comma, the 8th of June, period. Okay, so that is my entire string. It includes uppercase, includes letter or lowercase, spaces, commas, and even a period along with a number. Okay, so that is just my string. And let me comment the rest of this code out so I can just do it one at a time for you to see what it does. Give me just a second. Okay. So so here's my string, and what I want to do is I want to print it out. So I use the print command. Now this is for Python 3, Python 2 a little bit different. But when I run this, it's going to create a string in memory, assign it this value, then it's going to print it out. And it's going to print it out right here, but it's also going to print out the words initial. So when I run this, you can actually just do it by hitting F5. Now I'm running this on a Mac. It runs the exact same way on Windows. So if I run this, you'll see my shell restarted over here, and it output initial colon, today is the day, the 8th of June. So what it did is it output this string right here, initial colon, then it did a space because I separator here, then I got my string. So you'll see it output exactly the way I did it. Now, at least for the assignments in my class, it's easier if you just convert everything to either uppercase or lowercase. That way, you don't have to worry about is it an uppercase A or is it a lowercase a, so on and so forth. Now, in the real world, obviously, it wouldn't matter, but at least for my assignments, it's easier if you just do it so you don't have to. Now, I'm going to show you how to convert things to uppercase. And I made a comment here, convert to uppercase. So here's the way I did it. I took my string, said my string is equal to, this is an assignment operator, so my string is equal to my string converted to uppercase. I could have done lower, I could have done whatever, but upper converts it to upper. Now, again, I'm printing this out. Now this time I'm printing out a string called upper and then my string. Okay. Initially the string had uppercase, lowercase, and everything. But over here, now I'm converting it all to uppercase. So this output should say upper and it should be in uppercase. Okay, let's try it. We're going to save, and you'll notice now I get the exact same string, but now every alphabetic character, in other words, A through Z, has been converted to uppercase. It didn't do anything to the comma or the space or the 8 or the period. So I very easily converted it to uppercase. Now I'm going to show you a couple things here. Okay, I have a for loop here, and I'm going to show you a couple things we can do with it. I'm going to just leave a little bit of it commented out for the moment. What this for loop does is a loop that it goes through the string multiple times. So I said for x, it's just a variable. You could have put a or b or whatever you want. So for x in range, length of my string. Actually, let's see what that actually returns first. So if I type print len, actually we already saw print my string, so let's print len of my string. Len is length. So what this should give me, it should take my string and print out just a numeric value telling me the length of it. Okay, I'm going to try this. Save it again, and now you notice I got my initial string, my uppercase string, and the number 34. So what it did was it told me the length of it, and I could also, if I wanted to, I could put length, just like it did the other, so it matches. Now when I run it again, I should get today's the day, the 8th of June, blah, 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 and length of 34. Works very nice. So now I would go into my loop here. And this for loop says for x, that's my variable, in range, length of my string. So it's kind of like replacing this with the 34. Okay. Now, in Python, your loop has to have a colon at the end, and you got to indent the next line. So I'm going to say print x. So what are we going to get here? Now, x is a variable that's going to start at 0 and go up to just shy of 34. So in other words, 0 to 33. And it's going to print out, right now it's going to print out x. Now, depending on the kind of loop you use, it could print out the value of x, it could print out the variable, but in this case, it's just going to print out x, which in this case is a number. So if I do this, you'll see I'll actually get the numbers 0 to 33. You can see them right there. 0 to 33, all one on per line. That's not really what I wanted. I want to go through this string. So what I can say is I can say my string. Now I can use the square brackets here. And what that's telling me is my string 0, then my string 1, and my string 2, and so on and so forth. Is converting my string, is giving me one character at a time. So when I run it now, you'll notice I'm getting the exact string. I got length, and then I'm getting the exact string one. So today, space, is space, so on and so forth, all the way through the entire string. Pretty easy stuff. Now, I don't want to do much with that. I just wanted to show you what it was. Now, down here, I got some other code. Now, let's bring this code back in here. To make this work, first of all, I need this string. What I'm creating here is I'm creating a new string that's equal to nothing. That's basically what that line says. It says make it equal to nothing. Here I'm saying new string is equal to new string plus my string x. So if new string starts off at 0, or at nothing, I'm sorry. So new string is equal to nothing plus the first character in my string, which we saw over here was t. So if I do that, it's actually running through a loop and it's creating a new string. So this loop's going to go 0 to 33. So new string is equal to nothing plus the t. Then it goes back through the loop again. New string is equal to the t plus the o. Then we got new string is equal to to plus the d. So far, so good. Okay, let's run this. Now I gotta run this. I got nothing. Did that mean it didn't do anything? No, it just didn't output the results. Okay, so I'm going to go over here, and I'm going to uncomment out this. Now, I'm going to actually do it two different ways. I'm going to indent this the same exact level that I have new string indented. Forget this, we don't need this one at the moment. So we made new string, then I'm going to print this out. So what are we going to get? Let's see. Well, actually, let's talk about it first. So we have this loop that's going to go 0 to 33. So the new string is equal to, I keep adding. So I add the nothing, then I add the t, then I add the to. I add the t, then the o, and the d. Each time I'm going to print out this new string. So it's going to print out a t, then a to, then a tod, so on and so forth. Let's see what we actually get. Look at that. It's growing as we are. Now, the reason it kept printing each time, you see it added the t, then it added the o, then the d, then the a, and it kept appending to that initial string until I got the entire thing. Now, that's not really what I wanted, but since I have it indented under the for loop, that's what I got. Now, if I bring it back over here to the left margin, I run it, now the loop will run and it'll print out the string one time. Pretty simple. All right. All right, now, one thing I want to do, now, let me run this one more time so you can make sure it's still running. You'll see I'm getting, today is the day, the 8th of June. Now, if we're working with the Caesar cipher, we're going to have to shift the letters. Okay, now, when shifting letters, what I'm talking about is like the A, if I shift it by 3, so if you look at the alphabet, so if I was to put the alphabet down here, A, B, C, D, E, F, G, so I would shift it by 3. So 1, 2, 3, A, B, C, D, E, F, G. So what happened is the A shift by 1, 2, 3. So the A becomes a D, B becomes E, C becomes F, D becomes G, so on and so forth. Okay? Well, when working with the Caesar cipher, I don't want to shift numbers. I don't want to shift spaces. I don't want to shift periods. I only want to work with the letters. So how can I change this to only work with letters? Because again, when I run this, you'll notice I'm getting the entire thing, the spaces, the commas, the 8, and so on and so forth. Well, what I can do is I can go right here, and I can say, tab over, sorry, I can say if my string, now there's an error in here, I'm not going to fix it, is alpha. Now, this is an if statement. So for an if statement, just like a for loop, I need to have a colon at the end, and I need to indent underneath it. Okay, I'm going to make these line up a little differently. Okay, now when I run this, we're going to get an error. Okay, actually, no, it really didn't give me an error, but it didn't do what I wanted. So this is not really a runtime error. It's really a logic error, because what I told it was, if my string is an alpha, in other words, if it's an alphanumeric character, then create the new string. But when I went to print it, there was nothing. Well, the reason was, is alpha works with one character at a time. I can't pass it a whole string. To fix that, I just need to put the X there, just like we've been using it here, just like we've been using it here. So now it's going to go through the string character by character. It's going to take my string 0, check if it's an alpha. If it is, it's going to append it to a new string. So now when I run this, you'll see what happens. Now I get a string that is just the letters. Okay, the spaces have been removed, the commas have been removed, the numbers have been removed, the periods have been removed, all that stuff. So this is what you really need to do when working with the Caesar cipher, because you're not going to shift a 3. Okay, you're not going to shift a comma, you're not going to shift an 8 or a period. So now we have our string. I mean, it seemed like a lot of work. I mean, you could have gone by hand and just deleted the commas and the spaces and all that. But now it did it automatically. If I was to change the string up here, it'll happen automatically. Okay, so with the Caesar cipher, now we want to shift it by 3. Hopefully you know what the Caesar cipher is by now. So let's create another loop down here. For x in range. Now the length has changed because now it has no spaces. So I want to use for x in range of new string, because remember the new string doesn't have the spaces in it. What if I want to print out the specific characters? So I could say new string x. So what that'll do is it'll go through the string just like I did in the past and print out each letter. Just like I did before, but without the spaces and the 8s and the commas and all that stuff. Well, with a Caesar cipher, we have to shift it by 3. Okay, that was the original Caesar cipher. Now, there's a way you can do that. There's something called ORD. ORD, right? And if I put the comma at the end, this will return the ordinal value, or in other words, the ASCII value of this specific character. Okay, hopefully you know what ASCII is. Let's find out what ASCII is. What is ASCII? I have spelled what right? I can't even spell anything today. What is ASCII? Okay, it's abbreviated from American Standard Code for Information Interchange, so on and so forth. Wikipedia, a wonderful source here. And it'll, wow, that's a terrible graphic. Let's just go to images. What is ASCII? Now, if you were to bring this up, and let's go to potentially this one. Okay, so today is a T right here. See the T? And that's an 84. TO should be a 79. So if I print out TO, I should get 84 and then 79. Let's see what we actually get. Because I'm telling it here, print out the ASCII. I'm going to tell it even ASCII, so we know what it's doing. If I run it now, I should get 84 and 79. And it was there. I saw it. There's the 84. We know, according to this chart, that 84 right here is a T. 79 is an O. So TO for today. That's how we got that. Okay? It went through the entire thing, print out the ASCII value. But what if, again, with the Caesar cipher, I want to shift by 3. How can I shift this over by 3? Because we're printing out the ASCII value of the actual letter. Well, since really that is the ORD command right there, this is returning a numeric value right here, this section right here. Why don't I just increase it by 3? Okay. Now let's run this again. So if I did this right, the T increased by 3. 1, 2, 3. The T should become 87. and the O, 1, 2, 3, become 82. So I should get an 87 and an 82. Okay, let's see what I get. Again, I'm only looking at the first couple letters. So I think you already saw it. I got an 87 and an 82. So T shifted over to an 87. But man, that's tough. How do I know what that is? Well, let's see if we can figure out a way to do that. Now, what if, okay, so we used OR to convert to the numerical value or the ASCII value of the letter. Now I can use CHR, and I'm going to put that right around here. So what that's going to do is now we're going to take my string, get the ASCII value of it, increase it by 3, and now convert it back to a letter. So if I did this right, T, so T, let's see what T should become. Make sure I'm not losing my brain here. T, 1, 2, T should become W, and O should become 1, 2, 3, R. So I should get WR. Okay, let's run this and see what we get. Okay, well, I know it's went past it there. Sure enough, so T became W. O became R. Now what I could do, rather than just print these out, just like I did up there, I could say new shifted string. You can call it anything you want. Okay, then in here, I could say new shift string equals new shift string plus all this. So all this stuff right there. Comment this guy out. So what it's doing now is it's creating me a new string, again starting with nothing and adding each letter to it. So let's run this again. Now you should already see what I did wrong. If not, you're going to learn. It didn't print anything out. It's like, what the, first of all, I got a typo. New SHIFTED. New SHIFTED. Oops, I don't want all that. Okay, but that's really wasn't there I was looking for. There it goes. It didn't print out my result because I don't have a print statement. Now, what I can do is I can do just like I did before. I can print out new shifted string. And hopefully you know what that's going to do. It's going to print it out, but it's going to be over. It's going to get the W, then the WR, then the WRG, and so on and so forth. Well, if I move this back by 1, now it's going to print it out all on one line. Now, we do have a small problem, okay? The problem is this thing right here. See that? Right there. So that's the T, that's the O, that's the D, that's the A, that's the Y. Wow, what are we going to do? The problem was, if you bring this chart back up here, so we were converting a Y. This Y was an 89. We shifted by 3. 1, 2, 3. We got a 92, which is a slash. That's not going to work for us so well. So how can we possibly fix that? All right, now, so let's discuss this problem one more time. So when I run this, again, I get that whole slash thing is killing me right there. What can I possibly do to fix that? So that Y right here was an 89 when I shifted by 3. 1, 2, 3, got 92. But what should it have done? So that Y should have said 1 was a Z, 2 is an A, 3 is a B. So Y should become B. You agree with that? So if I shift the Y, 1, 2, 3, I should end up getting a B. How can I fix that? Well, let's look. Well, this 3, first of all, it's not a good idea to ever hard-code a value like that. But in this case, what I'm doing is do shift val equals 3. I'm going to change this to just be called shift val. So that way I can manipulate it easier. Now, when I run this again, see I get the exact same results, but I still got the problem. But how can I fix it? Well, right here before I actually do any shifting, what if I put a statement? If, I'm going to take this exact, not the whole statement, but just this one right. Make sure I got the right one right there. So what if I take that? Now the problem is going beyond a z. So what if I check and see if it goes beyond z? If it goes beyond z, that's where our problem is. So what if the string, all right, so what if the character shifted, or the ASCII value plus the shift, what if it's greater than 90? Isn't that our problem? Because if it's greater than 90, that's where I need to fix it. So what I can do, so if it's greater than 90, why don't I change my, oops, I forgot my colon. Shift, remember we're initially shifting it by 3. So if it's greater than 90, why don't I say shift x is shift value minus 26? Because basically we have the alphabet of 26 letters. So if it's greater than 90, why not subtract 26? And that will bring us back to an A position. Okay? Now let's see if that fixed it. It did, but it didn't. You'll see what I'm talking about here in a second. Okay. Huh. Well, looking at this one here, you'll see I've got the WRGD perfectly. Then I got this slash. Now, that was the Y. Let's go look at our code here. So the Y, where's the Y? There's the Y. Shifted by 3 would be 1, 2, 3. So we want the Y to become a B. We got it. Right there. The Y became a B. But what the heck happened to the A? Wait a minute. I'm sorry. Not the Y. The I become a 2. How did an I become a 2? What did I screw up? Well, we told it if the shift value is greater than 90, then subtract 26. Okay, and the problem is once we did subtract the 26, there is another way to do this, by the way, with modulus, but I'm not covering it today. So what else can I do? What if I said else? So if it's not greater than 90, then set it back to 3. Let's shift val equals 3. So if it's not greater than 90, let's set it back to 3. Let's see what we get. There we go. Look at that. Amazing, isn't it? So it took remember we had the problem with the Y. The Y became the B. Then the I became the L. So it fixed our entire thing. So this string shifted with the Caesar cipher of 3 becomes this string. Now I'm going to take that string out. I'm going to go up into my code. I'm going to say decoded. No, I'm sorry, encoded. My bad. Okay. Now we're going to play with that. We got it encoded perfectly. We took our string right here and we encoded that string to that perfectly. Now, how can we possibly undo it? Well, let's see. All right, now what I did is I took the results right here. Let's run it one more time. Make sure we're not lying. I took the results. So this string encoded becomes this. Okay, so now it's encrypted basically, so we can't read it. So what I did is I took that result, put it up here, and I just called it encoded. Okay. Now some of my print statements aren't going to be correct anymore, but I'm just going to leave them there, so we'll have to disregard a couple of them. But I want to modify this section down here. Now there's a much easier way to do this, but I'm not covering that right now. I'm just trying to get this as easy as possible. Okay, what I can do is now since we're working with new string, I'm going to say, hey, you know what? My new string is equal to the encoded. Okay, now when I run it, you'll see it took it and even shifted 3 more farther. Because remember, we had W became Z, and R became U, but we want to undo it. So in other words, we need to shift backwards. Well, you'd think I could just put a minus sign here. In other words, a -3. Yeah, not gonna do so much. So what we need to do to fix this, let's change this. Instead of adding the shift value, why not subtract the shift value? Because we want to go backwards now. Again, still not totally correct, but let's see what it does. Hey, we're making progress. Because remember, now we're taking that W string, the one right where we're taking that string right there. Now we're going backwards. So we almost have it. But what's going on? Okay, it's this section right here. Okay, so we're checking if the shift value is greater than 90. Well, let's go look at our ASCII chart. So now, remember, now we're not adding 3, we're subtracting 3. So most of these won't give us a problem. The ones that are going to give us a problem, so if it's, see this, how an A is a 65, and see down the Z is a 90. So we're checking if it becomes greater than 90. If it does, we're subtracting 26. Well, why don't we check if it gets below 65? So let's do that. So rather than greater than 90, we're going to check if it goes below 65. And should I subtract 26? No, I should now add 26. So let's see what we get now. Well, it's close, but not quite there. All right, I'm looking at my code here, and I you know what? I'm going to show you a little bit easier way to decrypt this. Okay, we got our new decrypted string here, and when we run this, we're getting an error. The error we're getting is because the way I'm shifting it. Not really the best idea to do this. So what I'm going to do is I'm going to take this code, I'm going to put it down here. Okay, and then that. The reason, actually, let me go back a second. The reason, well, the problem we're having is the shift value is compounding itself, and it's making shift farther down than what it needs to do. So I'm going to take this, put it right there. I'm going to copy this string because I need to shift it 2 different ways. I want to get rid of all this. Now what I'm going to do is go all the way up here, and I'm going to comment this out. Now in idle, you can actually do format, comment out region. So that part will no longer do anything. So now if the shift value is less than 65, so in other words it's less than the A, we're going to do this first thing. And else, we're going to do this second thing. Okay, now I need to change, I need to knit this. I need to change what this one does. So if the shift value, after it's been shifted, it ends up being less than 65, we'll still go ahead and shift it by the negative 3. Then we're just going to add 26 to it. If I can get my cursor to work. So in other words, looking at my little chart here, if I have a B and I go backwards 3, I go 1, 2, 3, I ended up at a 63. So I'm less than 65. What I'm going to do is I'm still going to subtract that. So I'm going to end up at 63, but then add 26. So I get back up to where I need to be in the alphabet. If that's not the case, I'm just going to shift it normally. So let's see what we get now. And there we go. So remember, this time we're working with encoded string. Actually, let me change that to say encoded. So now we're working with encoded. See if that actually outputs what we want. Now let's get rid of this whole. It's already upper, so I'm going to get rid of these. Get rid of this. Get rid of this. No, that's not where you're supposed to go. Get rid of that. So now we're just really seeing what we get. So the initial is now this. So remember, we took this string and shifted it by 3 to get this. Now we're taking this string, shifting it backwards to get to the original string, so it works perfectly. Now, normally you'd write this in methods and you'd use the modulus, but I tried to make it just so it was really basic stuff, didn't want to cover too much stuff here. But it does seem to be working now. So, yeah, it was a dumb idea to do that way. I don't know why I did that, but this way it will work much better for you. So again, once we shift it, remember this is the ASCII value. Once we take the ASCII value and subtract 3, in this case, if that's less than 65, so in other words, if a B ends up being, whatever that character ends up being, then what we do is we still subtract the 3, but then we just add 26 to it. So when the B went back 1, 2, 3, the question mark, ended up being a 63, we went ahead and subtracted 63, or subtracted the 3 to get to 63, but then we added 26. So we took the 63 and add 26, you're going to get what, 89? 89 ends up being the y, is the character we want. So that solved our entire problem. If it's not less than 65, then just subtract the 3. Pretty simple stuff. All right, that should give you an idea how to do it. There's a much easier way to do it, but again, this will work for now. All right, well, thank you much.